what's this about an engine of your own here?
So we have some designs in team based on everything we learned in the X Prize and everything we learned while we were campaigning in the X Prize and everything we learned from the other people campaigning in the X Prize.
Yes.
And it would be a very different type of engine than what's currently available. We don't yet have the machine to fabricate, to test it. We would need about a $30,000 high-strength Z-axis CNC mill, which is a very inexpensive type of mill relatively, but right now we don't have one. Once we do, we will prototype that engine and find out if it works.
What kind of engine is this now?
Oh man.
A rotary engine?
It's pretty different.
Is it a piston engine?
It's a 64 cylinder with a bank of potentially 124 cylinder. It can be run in 2-bank. It has more in common with the Intel Core i7 architecture than an existing internal combustion engine.
Is it chemical fuel?
Yeah, it's compatible with, it's an internal combustion engine with a very different type of architecture. I'd love to test it and see if it actually functions. In simulation, it's phenomenal. We'd have to find out if it actually plays out in reality.
Is this prediction a consensus of a lot of leading people?
Oh, I wouldn't say that yet. The idea has been floated around Team Wikispeed, which is about 150 people, including some leading people, like the guy who founded the Material Science Lab at MIT, the guy who ran the largest military research facility in the world, a lady who did electrical and mechanical engineering for NASA, Lockheed Martin, and was a tech on the first Apple computer multimedia PC. And it looks promising, but until we actually have a functioning prototype, I wouldn't be able to say yes, it's going to happen. It's a good idea, is where it is, and we're excited to try it.
In alternative designs for engines, the team members are constantly bringing up interesting new developments, rotary engines or engines that use sonic waves in a special way. And what I would say to anybody developing those kinds of engines is, why not adapt one to our engine module? It's relatively simple.
And a common question is, once again, why haven't these engines been developed?
So far, I'll say every engine that has a higher brake-specific fuel consumption than the engines we're using now, the Honda R18A, which then we make a tiny improvement to, but tiny. Honda's very smart. We didn't figure out much that they haven't already tried. Every engine that would be more efficient than that has been fragile or not yet real. Now that doesn't mean those designs aren't going to do amazing things, but what we've been able to say is, fantastic, please loan us a version of your engine that can produce right around 50 horsepower. That allows us to get to highway speed at American levels of acceleration because our vehicle is light and aerodynamic. And say that it'll run for at least 36,000 miles without having to be rebuilt, standard maintenance only. And none of them have been able to deliver that yet. Now that doesn't mean the technology that is being developed outside of Team and in Team isn't going to lead to amazing revolutions in engine fuel efficiency. But as of yet, there is not a durable prototype that anyone's willing to show or at least have us test in our chassis.
Are you requiring
can produce 50 horsepower and not require a rebuild for at least 36,000 miles?
Are you requiring open source versions, or anything goes here?
Anything goes here for testing. We're compatible with standard capitalism and restrictive IP. We care about revolutionizing the world and making the world a better place. And the fastest way to do that, through ultra-efficient cars, as the angle we're taking now, is the most useful. If we can have these open source components in every garage in every country and in every field in every country, that's a definition of the world being a better place, because now it's ultra-efficiency actually being utilized, and that's the goal.